In this talk, I'll first explain how particle interactions create space-time, and second, why the space-time that's created looks like wave functions at the quantum scale, but is relativistic at the classical scale. This is all explained in detail in my book, Universal Reality 2.0, available as a free PDF version at edgarallowen.com/reality.shtml. Particles can be thought of as valid sets of particle components. Particle components include mass and the other force charges, spin, energy, and momentum. Particle components are the fundamental elements it takes to make actual particles. These particle components should be considered the true fundamental units of reality because they're conserved, with rare exceptions, in all particle interactions, but particles change into other particles and are not conserved. So when particles interact, all their particle components are conserved. This establishes relationships among particles on their particle components called quantum entanglements. For example, the conservation of energy and momentum in the interaction of two particles determines their relative positions and velocities afterwards. This is how particle interactions create dimensional relationships among particles. These dimensional relationships among particles and objects are interpreted as a dimensional space by our brains. The result of all particle interactions over the history of the universe is a single vast entanglement network dimensionally relating all the particles in the universe. These relationships are stored in the particle component values of all the particles in the universe. Our brains then sample these relationships at the emergent level of particulate objects and simulate them as a world of objects within an empty 3D space. But that empty 3D space doesn't actually exist. All these particle interactions and dimensional relationships are actually computed in the computational space of the quantum vacuum in the same manner that actions in a virtual reality are computed in a computer memory and only seem to take place in a 3D space in a virtual reality headset. It's our human brains that interpret these dimensional relationships among objects as a 3D space. The dimensional space we seem to see around us is actually a mental 3D graph constructed by our brains within which it places objects based on their dimensional relationships. This simulated 3D world constructed by our brains makes it easy for us to see the dimensional relationships among objects and for us to function effectively. Thus, the apparent 3D universe is an adaptive illusion that evolved because it greatly increased our chances of survival. So the encompassing dimensional space we seem to see around us is just a highly adaptive illusion created by our minds. We seem to live in a physical dimensional world, but it's only a simulation in our brains. This may initially appear counterintuitive, but consider this. We never actually see empty dimensional space because emptiness is non-observable. All we actually see is dimensional relationships among observable objects, and this is what actually exists. Also, cognitive science confirms that the physical dimensional world we seem to see around us actually consists of neural data structures in our brains. Thus, it's really quite clear that dimensional space is created by quantum entanglements computed in the computational space of the quantum vacuum and only appears as a physical dimensional space in our brain's simulation of reality. Okay, this is how particle interactions create what our minds interpret as dimensional space-time. But how does it explain quantum wave functions? Each particle interaction is computed as a coherent process. This means that the dimensional relationships of the resulting particles continue to have the exactness they were created with within the process. However, each coherent process is computed with a minute quantum scale random conflation of space and time velocities, as explained in previous talks. Since each coherent process is computed with a different random conflation, the dimensionalities of coherent processes have minute quantum scale random uncertainties with respect to each other. This is why they look like wave functions to each other and to observers. So each coherent process is in effect a fuzzy dimensional fragment, and the entanglement network of the dimensional relationships of all the particles in the universe is knitted together from these fuzzy dimensional fragments. Now, when particles from different dimensional fragments interact, they must have exact dimensional relationships with respect to each other for energy and momentum to be conserved. So their wave functions randomly decohere to exact values and begin to interact as a new coherent process. This is how what we call space-time is constructed from zillions of fuzzy dimensional fragments. Since space-time is created by particle interactions, it's automatically consistent with quantum theory at the particle scale. And since the dimensional relationships created are scaled by the presence of mass energy, space-time is automatically relativistic at the classical scale. In this way, quantum theory and relativity are unified in a single computational theory in which space-time is created by quantum entanglements. And since computational space is inherently non-local, quantum paradoxes all vanish, as explained in detail in my book Universal Reality 2.0.